Millions of people throughout the world have to deal with acne, and most people resort to skincare products in hopes to prevent future breakouts. With thousands of products to choose from, it can be very hard to know what product will actually work for you. Since many products contain unheard of ingredients, it is hard to know what it will do for your skin. Salicylic acid, a common ingredient in many acne-related skincare products, is mainly used in hopes to reduce acne. More specifically, salicylic acid reduces dead skin, unclogs pores, and reduces inflammation. Salicylic acid is also commonly used to treat dandruff, warts, and psoriasis, all different types of skin conditions. But only very low concentrations of salicylic acid are used in products and treatments, 3 to 6%. If any higher, it can actually cause damage to the skin. Here are some examples of products that you can find at your local drugstore. Salicylic acid is able to form hydrogen bonds. There are 2 hydroxyl groups and 1 carbonyl group present in the compound. The combination of one of the hydroxyl groups attached to the carbonyl makes up carboxylic acid, whereas the remaining hydroxyl group attached to the carbon ring makes up phenol. Overall, salicylic acid is not very soluble in water or polar. It is only soluble 0.2 moles per liter, but it is lipid soluble. Salicylic acid being lipid soluble gives it the ability to reduce the appearance of acne by breaking down the sebum and excess skin tissue. More specifically, salicylic acid works as an exfoliant peeling agent for the skin by breaking down the keratin. With that, salicylic acid is able to even out the skin texture and soften the skin. It also reduces the appearance of redness and acne by breaking down the dermazones of the dead skin that clogs the pores. Dermazones are part of the cell that is responsible for holding the cells together. To synthesize salicylic acid, you start out with a solution of sodium hydroxide and water, and then add phenol to the solution. Eventually, after frequent storing, it forms sodium phenoxide. Sodium phenoxide will then react with carbon dioxide. The product will then be deprotonated and neutralized by hydrochloric acid, forming salicylic acid. Salicylic acid is also a precursor to aspirin. This means that aspirin is prepared from a chemical synthesis of salicylic acid. Salicylic acid is a naturally occurring compound from the bark of willow trees and spirea bushes.